Hey everybody, my name is Sloan and I'm a robotics teacher at the Dalton School where I teach some of the people in the room. And today I came in to talk to you a little bit about a program that some of you might be interested in at least knowing exists called RoboCup. So Katie's done it before and some other people may have heard of it before, but what RoboCup is basically, long story short, RoboCup is an international organization whose stated goal is to build robots that can beat the FIFA World Champions in soccer by 2050. So it's a relatively ambitious goal, but they're moving towards it. And it basically spans all the way from middle school robotics as just a basic introduction to robotics, all the way up to a number of different colleges have programs in different leagues that are accelerating quite quickly. So this year, I coached the team that was lucky enough to win the U.S. competition and go to Brazil as the middle school U.S. representatives. I just got back yesterday, so forgive me if I'm still a little jet lagged. But I figured I'd come in and talk to you a little bit about my experience with that and the program and just talk about it. Okay, so long story short, RoboCup is played in about 20 or so countries all over the world, and every year they have a competition in a different country where the different countries come and compete and play some version of robot soccer. So at the very youngest version of it, the robots look something like this. So these are the robots that competed for the US team. They're almost all little tiny holonomic robots. The limitations are, there's a size limitation, so it has to fit inside of a certain circular sizing cube. There's a voltage limitation for how much voltage you can put in, and there's a weight limitation, but that's it. You can use any parts you want. You can buy any sort of sensors as long as you're able to understand them. There is a limit that the students need to be able to prove that they actually built the robot with sort of limited help from mentors and not just putting together a kit, but even that's sort of loose, to be perfectly honest. So it's very different from other robotics competitions that you may have heard of, like FIRST, where they give you a standard kit of parts and you sort of, and the challenge is that the competition changes every year. Every year it's the same competition and teams just continually improve their robots every year in that. So this is my student's robot. You can see it's relatively simple for those of you who maybe used Arduino programming before. I got multiple of them, so pass one around to you. It is plugged in, so don't hit the giant green switch or it'll start trying to run away from you. So how the competition works is, So there's a small soccer field that's maybe, I can't even remember, 7 feet by 3 feet wide, and has all the normal markings of a soccer field that you might be used to. So a white outline that the robot needs to stay in bounds from, and over the course of the match, it tracks a soccer ball that emits an IR pulse as it's going along. So basically, all the robots need to track the ball using that IR signal and then move it and play soccer, basically. All the normal rules of soccer apply. You can only have one goalie inside of the box, but everything else is pretty much the same. But so the middle school robots, since I don't have any picture, these guys are they basically just hacked into these are pre-made Tetrix Lego sensors, one that's an IR array, one that's a compass to make sure the robot's pointed towards the goal that it's going towards, and then it has a reflectance sensor sitting on the bottom that it's using just to stay inside of the white lines as it's moving along. So the basic soccer playing robots that they play, you play with 2 on the field at any one time. Generally, one is a goalie and one is a striker, but you're allowed to modify it at halftime or between rounds. You can have 2 strikers on the field at one time if you want. If you're really far behind, you can modify the code at halftime if there's any problems with it. But as it gets older, basically the competition scales up where the weight limitation gets relaxed. So many of the high school robots have things like pneumatic kickers on them in order to kick the ball, or dribbling mechanisms that hold onto the ball. You're not allowed to possess the ball, like fully enclose it, but if you have a mechanism that rotates quickly and sort of holds the ball just for a second while spinning it towards it. You can hold onto the ball for extended periods of time. And so at the very highest level, the robots in high school are possessing the ball and holding onto the ball, and then turning and using webcams and vision processing software to see the goals, and then once it sees the goals, shooting it with a pneumatic kicker. And so at the highest level, these things are actually relatively dangerous to have your hands around because of quite a bit of force. So that's only a little part of the international competition. So at these international competitions, this is a division called RoboCup Jr, which primarily, these robots aren't going to beat the FIFA World Champions anytime soon. But it's sort of just an introduction to robotics for younger students. But once you get to the collegiate level, there's about 12 different divisions of robotics that you can do. From all the way to one division is completely a simulation, so the robots are all, there's no physical robot, you're just coding the behavior of little dots on the screen, to giant child-sized humanoid robots that I have pictures of, but see if we try one. Nice. Okay, so this was just a brief shot of the convention center in Brazil, where the RoboCup was held. So it travels every year. Next year's in China. Last year it was in Copenhagen. So this here is one of the college level robotics competitions. So you can see the field is relatively large, and in this competition, so it's going this way. There's two different fields. In this competition, you have a team of 5 different little robots, and you're using a camera above to track where your robot is, and it's all autonomously programmed. So at this level, robots are passing the ball between one another, getting angled on the goal, and moving relatively fast. This is one of the fastest divisions of it. The humanoid robots, there's a couple different divisions of the humanoid robots, from prefabricated robots that you can just buy, called the Now. I don't know if you've ever seen it. I know they visited Dalton with one once. To this is a homemade college humanoid robot that instead of having anything emitting from the ball in order to track it, it just needs to use vision processing software to see the giant orange ball and then go around and kick it. They move very, very slowly at this point, but part of the rules is that the robot needs to be able to get up once it falls over, which is trickier than you might think for moving around, especially when it's getting on one foot in order to swing and kick the ball. So this is an example of what the field actually looks like. So these are the older high school level robots here. And so you can't really see it on here, but these each have pneumatic kickers and a bunch of different sensor systems, including ultrasonic to see where they are on the field, compasses to stay oriented towards where the goal wants to be, and so on and so forth. So there's two 10-minute halves. There's no remote control whatsoever, so all of the robots are pre-programmed, and you just set them back up and keep going. And then at the young level, so the level that these robots were programmed to compete in, there's 2 different competitions. One is the one I just showed you, that has you bring 2 robots and you just compete against another country. So it's one country versus another country with 2 robots. Again, usually one's a goalie and one's a striker, but that's not necessarily the case. The second level of competition is what's called the super team. And so it's a much bigger field. And for the super team, they take 5 countries and pair them up with one another, and you compete against 5 other countries. And so the interesting thing there is, as soon as you get assigned to a super team, you have to modify your program and modify your chassis in order to work with the other robots. So, for example, our team got eliminated on the second day of competition by Portugal for the individual competition. They split the first day, they beat Brazil and lost to Japan. The RoboCup world rankings are very different from the FIFA world rankings. But on the second day, lost to Portugal and were kicked out. So they focused their efforts on the super team, and specifically, they had a particularly good goalie this year. Just something about their program made it work exceptionally well. And with the help of the Chinese striker that was also on their super team, they ended up winning the super team competition and altogether. So overall, the U.S. team this year won the super team competition, placed third in best robot design, and it's for it's totally tracking my touch, isn't it? For reasons you might not think of. So these are relatively simple robots. At the competition, you see much more complicated robots. But one thing my students made a very conscious effort to do is make it as simple as possible and make it as easy and make it as unlikely to break as possible, because a lot of these robots need some really constant maintenance. So as an example of that, so my team has competed for 2 years. This was their robot last year, right when they were first learning how to, basically learning how, was an introduction to programming for many of them. Some of them hadn't ever programmed before they started doing Arduino for this competition. So you can see it's a huge rat nest of wires, with a bunch of different motor controllers and sensors. And at the New Jersey competition last year, one of them caught on fire, right? Because it's sort of the nature of the competition when you let middle schoolers just really explore and build. And so that was their very first robot last year. And then last year, that by the end of the year, they had made these robots here, which are still much, much more complicated than the robots I brought with me today, but much simpler than the first one. And so really for them, it was a lesson in being overly complicated and getting something that would just work, and then simplifying it down and making it much more reliable and much, much simpler. So the final robot that you're seeing here basically has 3 motors, all with holonomic wheels, a single Arduino, a single motor shield that controls the different motors, and then they, on the motor shield, basically soldered their own circuits in order to get the compass and IR sensors to work, and the reflectance sensor. And that's basically it. It's a very, very simple robot. They're at the point now where if anything breaks on the robot, they can basically rebuild a new robot in about an hour. Or there were multiple times where in transit on the plane there were a bunch of problems that came with it, and they were able to fix it relatively easily because it's a pretty simple robot. Alright, so I already saw that there's some holonomic chassis already here that look pretty close to it. So this is a competition that happens every year, and again there's many, many different divisions that all focus on different aspects of it, but the one making these little holonomic chassis and programmed to play soccer, it's a pretty cool one, and it's one that other countries take really seriously, and America's just starting to get better at, starting to get competitive with. And so it's definitely something that if you're looking for an interesting project to work on, you should check out RoboCup and see what it's about. So, I've talked for probably too long. Anyone have any questions? Yes?
What grade was that?
So these were 8th graders. Okay. So they started with that giant rat nest was when they were in 7th grade.
Yeah.
They now have aged out, so they're all going into high school. So they either have to go into the high school division, or actually all of them are moving over and doing the first competition next year. So, yeah.
Would I be able to find the code that this Arduino uses, or is that like all shut down so other countries can't see it, kind of thing?
Yeah. So it's interesting. The code's much simpler than you would think, but there's unfortunately some countries are very, very competitive about this. And so the culture of RoboCup is a little exclusionary at the moment, although they're trying to fix that. But at the same time, most of the libraries that you'd need in order to run the sensor systems or just run the motor or do all the simple stuff, that's totally open. And those exist and are really easy to find online. But then the actual code that it's running, because the students need to write it all themselves, the mentors aren't even allowed to debug the code. So we can show them common errors in other types of code and things like that, but technically we can't debug the code or help them really write the code. And technically, we're not even, even anything that breaks on here, we're not allowed to touch this once it's ready for me. Any questions? Yeah?
What about in respects to robots, well, I guess entanglement, fouling each other, fouling.
Yeah, so they slam into it. So depending on the level, with these motors, these are relatively robust ones and relatively slow versus some of the higher ones. But in the high school and college levels, they will just slam into one another and parts go flying, and it's kind of great. So I'm also a ref for RoboCup for the higher levels, and they're totally allowed to slam into one another. That is totally legal. They're allowed to push each other around, totally legal. If the two robots are slammed into one another and the ball is stuck between them, we count for 5 seconds, and if the ball hasn't progressed, we just break them up and put the ball back. And you can't push a goalie, but you can slam it. But there's no, the only penalty is you just break them apart. And so a big part of it is making really robust robots that are basically tanks and can't break, or are simple enough that you can fix them quickly. Because if anything breaks, you just take it off and you can fix it right by the So, but again, only students can touch it. Yeah.
So actually, when you go to make robots that more easily break up those robots?
Yeah, so there aren't specific rules against it, strangely enough. So the ref would pull it, yes, but there are definitely robots that exist that are made to be a little bit more robust in the front end that's slamming into the other robots, if that makes any sense. But you could not have,
Like spikes?
you could not put spikes or like a hammer or, no. It's unfortunately not the robotics fighting robots competition that exists. Yeah.
How many countries compete in robots?
So there were 13 countries for the middle school level. There's more for high school, and actually less for college, but there's more individual representatives from, so more than one US team will go for the different college levels. But yeah, for middle school, it's 13 countries, I believe. Yeah.
So that there's a level where like the robots can make angles and pass amongst each other.
Yep.
They're like offsides and like those kinds of rules.
Yes, at the very highest level. So at the very highest level, basically imagine this, but it's this high, right? And they're communicating with one another. It's still autonomous, and at that level, there's offsides. There are some limitations about how heavily you can slam into one another. Basically, the larger it gets and the closer it gets to actual soccer, the more rules they put in. With this, like if you saw the size of the field, it was so small that you always there's no offsides. They're just slamming into one another. Yeah.
Is there like an equivalent of a handball where like there's some things that a robot's not allowed to do?
Yeah, so you can't, all robots have some way of controlling the ball. So in this one it's really simple. Just part of the deck has a scoop that the kids designed in order to hold onto the ball. And for this one specifically, you can see from the version number on top of the deck, they went through at least 20 different versions of the scoop in order to see exactly what held the ball the best way. You can't hold, more than half the ball cannot be within your robot. So you can't have the ball in the middle of the robot and just drive it over and just go into the goal. And you can't hold the ball, so you can't grab the ball or clamp onto the ball. But again, there's ways of getting around that. So just like, in soccer, if you're passing the ball between your feet, you can have something that kicks the ball back into your robot, but just does it periodically rather than clamping onto the ball, and that's totally legal. And a lot of teams end up doing that for their striker. Yeah.
Shoot the ball out.
Yes. So there's a number of different ways to do that. The simplest one is just with a solenoid. So a lot of robots will have just an electronic solenoid on there. Now that pulls quite a bit of current and really pulls a lot of voltage out of your battery if you do that. And so pneumatics are also legal, and so you'll see a bunch of teams with basically soda bottles on top of their robot that are pressurized, that whenever it holds onto the ball, it just shoots the ball. There's a limit to how hard you can shoot the ball, because even at that competition, there were teams that just kicked the ball and just shattered the ball because they were doing it too hard, and I had to kick one team out for having too hard of a kicker. There's basically this little ramp that we test to see how hard you're kicking the ball, and if it goes up and over the ramp, it's too hard. But yeah, the kickers can be very useful, especially in conjunction with that dribbler. Because if you have the dribbler and you have a kicker, you can sort of hold onto the ball and then face towards the goal and then stop the dribbler and shoot it. And the German team's robot was an amazing example of that, where all the different decks were printed PCB boards, and it was beautiful, and it was a freaking tank. It was great. That was my favorite one.
If the robot just like a part just breaks and stops working like in the middle of the field, do you like go and fix it, or do you have to wait till like halftime?
Yeah, so if a robot breaks, you can say that it's broken, or if a ref sees that it's broken, we'll pull it. So all the penalties are off the field for a minute, or until the next goal. It usually is the next goal because a 1-on-2 for this competition, they're going to score within like 15 seconds. But if you have a broken robot, you can pull it and you can fix it right there. You can also change code right there. And so there's basically pit crews that as soon as the robot comes out, they're frantically fixing any problems or changing. Even simple things like with a goalie, it's really important to match the speed of the goalie with the speed of the strikers you're playing against. Because if it's too fast and the other thing's too slow, it can sort of overshoot when it's trying to stop the ball. And so one big thing is like within the first minute or two, pulling the robot and changing the code in order to, and making code that's really flexible in order to change it quickly so that it reflects what you want the robot to do. Yeah.
Is the match 90 minutes?
The match is 2 10-minute halves with 5 minutes in between to make any changes that you want. Yeah.
What's the typical score for one of these matches?
Yeah, so there were a lot of blowouts. So a competitive match will often be like 11 to 13. There was one sort of epic Chinese robot in the middle school competition that after 3 matches had like I think it was a 67-point goal differential, where they were winning like 20-1, 30. Yeah, it was crazy. But so it'll be roughly between, like the low end will be 8 or 9 to all the way to 30 if it's just like goal. But yeah.
Can you have a spare robot?
You cannot have a spare robot. You can only have 2. You can bring whatever you want to the competition, but you only get 2 robots inspected, and you can only have those 2 robots. So my kids, for example, had a fully, a 3rd robot that they had completely taken apart. So they had all the parts for a 3rd robot, but they technically couldn't use that. They just had all those parts so that if anything broke during competition, they could quickly fix it. So, yeah.
Wait, could you then get a robot like inspected for like, the strength of its kick, and then when you're fixing it later on, just modify it so that it would no longer pass inspection?
Yeah, one of the Japanese teams that I ref for tried to do that. Because you can, especially if you wanted to, you could set it in the code how hard the kicker is. And a lot of the high school robots will have processors on board and like keyboards on board so that you can change the code right on the robot rather than having to upload it to a computer. And so I had to stop a match and kick out a Japanese team that had a too strong of a kicker. Granted, they still won. It was 1-on-2 and they still won, but it was a good robot. Yeah.
Are those matrix motors that you're using?
The Pololu motors.
Huh?
Pololu.
Oh, okay.
Pololu.
Have you thought about using, I know that you're using the Tetrix compass sensor and an IR sensor. Have you thought about using that with NXT and Robot C?
Yes. So there's always a couple NXTs there. For their processing power, they're relatively heavy because
Yeah, they are.
that whole brick, right?
Yeah. It's
and
great,
so we were way under the weight limit, so we probably could have gotten away with it. There's always a couple NXT robots to start.
Yeah.
NXTs do not, going from NXT to a Holland Armor chassis is kind of tricky. And rather, going from an NXT to a motor controller to use sort of better motors that are available for Lego, that's a little bit tricky. But some teams absolutely do that. I also just hate programming in NXT. Robot C is okay.
No, I really like Robot C, but just the NXT does take up a lot of
It's
space.
a lot of space.
I do,
It's fantastic.
I actually do first, so I work with NXTs a lot. Yeah.
Nice.
They're a lot of space, but they're really, they have a lot of functions though, if you really start exploring.
And they're
Yeah.
really hard to break, which is
Yeah.
nice too.